Welcome back, Chemistry 30. So this is MS 3.4, alkynes. So we've looked at alkanes, alkenes. Now we look at all kinds of molecules. So we'll describe what the alkyne hydrocarbon group consists of, write the molecular and condensed structural formula and the IUPAC name for alkynes that are straight chain or branch chain, and state some properties, of course. So as you can predict, alkanes had single bonds, alkenes had one or more double bonds, so alkynes have at least one triple bond. And of course they are unsaturated, so they contain less than the maximum amount of hydrogens because they have a triple bond. So they have fewer than the maximum number of hydrogens. So if I have two carbons bonded together, a triple bond here, I would only need one extra hydrogen. And note that the more bonds that occur, going from single to double, triple, the closer they get to each other. Because over here, you know there are 6 electrons. Electron, 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 electron. And you can think of those electrons as being like glue, pulling them closer to each other. Also, that's going to be more reactive, as we'll see later on, because of those extra electrons that can move around. So like alkenes, alkynes cannot rotate around that triple bond. Unlike alkenes, however, the triple bond carbons and alkenes can only bond with one another element. Therefore, we don't have geometric isomers because there is only one option here. Just carbon bonded to one other item. In this case, it's an H. Alkynes are named in much the same way as alkenes. Their names are formed by changing the ENE to YNE, so that ine indicates that it is a triple bond. And just like before, pent, of course, that would be 5. 1, 2, 3, 4, 5 are in the longest chain. And again, you can see we number it in such a way that we get to the triple bond the quickest. So I number 1, 2, 3 versus 1, 2, 3. So at position 4, I have a methyl group. And then at position 2 is the beginning of that triple bond. So 4 methyl, 2 pentyne. So as we'll see, very similar to how we name alkenes. So if we look over here, so the longest carbon chain, again, we're looking at carbons, not H's. And yes, the triple bond is here, so I'm forced to number it this way, 1, 2, 3, 4. So I know 4 is bute. There's a triple bond there, so it's ine. There's no, see these H's just go along with the carbons to fill in the gaps. There are no ethyl or methyl groups. So I just have to indicate where that triple bond is. 1 butyne. Over here, hex means 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And notice, ine means triple bond, and there's a di. There's going to be 2 triple bonds. 2 triple bonds at positions 1 and 3. So at 1, there's a triple bond, and 3 marks the beginning of the other triple bond. And there are no other methyl or ethyl, so that's it. So this carbon bonded to 3 things needs 1 H. This carbon, 1, 2, 3, 4, it's good as is. Same thing with this one, 1, 2, 3, 4, we're good. This carbon, 1, 2, 3, 4, we're good. This carbon, 1, 2, so we need 2 H's. And this carbon's bonded to one thing, so it needs 3 H's. There we go. This one, if you want to pause the video and maybe try these, you certainly can. If you had a chance to try them, we can see that this is going to be a very long section, so I'm likely going to go there. Let's see, going 1, 2, or 1, 2, or 1, 2, 3, likely this way will give me the longest chain. And numbering it 1, 2, 3, 4, 5 versus 1, 2, 3, yes, so I have to number it this way. So notice this one has a combination of like not showing the bonds, but just look for carbons. Count the carbons and you can't go wrong. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 carbons there, so that's going to indicate octyne. And that triple bond starts at position 3. So position 3 is where I'm going to put that. And oh, we have attached groups here. Look at that. We have some methyls. we have some methyls, and those methyls are at positions, let's see, 1, 2, 3, 4, 5, 6, and 6. So 6, 6 dash dimethyl dash 3 octine. There we go. This last one, bute, of course that's 4. Ine indicates a triple bond. There's no prefix in between here, so there's just going to be one triple bond at position 1. And 2 methyls at position 3. Oops. Let's just move that on over here. 3, 4. So at position 3, I'm going to have a methyl and another methyl because it's di. And then just fill in the H's. I'm going to need one there. 1, 2, 3, 4. 1, 2, 3, 4. This carbon's good. This carbon, 1, 2, 3, 4. He's good. This carbon, yeah, I need the extra 3 at the end. There we go. 3,3-dimethyl, 1-butyne. All right, so properties of alkynes. They have physical and chemical properties similar to those of alkenes. Many reactions that alkenes undergo, alkynes undergo. However, alkynes are more reactive, just like I mentioned earlier. Triple bond even indicates more electron density than that of the double bonds. So that those 6 electrons, that cluster of electrons, is effective at inducing dipoles. Again, we have those dispersion forces, those electrons just happening to end up on one side of the molecule, making it slightly negative, causing the other side to be positive, and of course causing nearby molecules to become temporary dipoles. And more information on the next page. Ethyne, so 2 carbons, like that. We're drawing with a highlighter, but there we go. Is a byproduct of oil refining and other circumstances. When supplied with enough, that should be supplied. Goodness. So when supplied with enough oxygen, ethyne burns with an intense hot flame that can reach temperatures as high as 3,000 degrees C. And of course, the common name for ethyne is acetylene. And you have heard of acetylene torches, likely used in welding. Since the triple bond makes alkynes reactive, ethyne is used as a starting material in the manufacture of plastics and other organic chemicals used in the lab. Right, so you should be able to do, the assignment just simply deals with naming and formula writing of alkynes, so you should have no problems with that. All right, we'll see you again.